We will be given an introduction to the session by Dr. Glenda Cruz, and I'd just like to give you a brief introduction about her. So she's the executive head of the Center for Science, Technology and Innovation here in the HSRC. She has a particular interest in how institutions interact to build their capabilities, and then how they then link with marginalized communities to help embed STI, in those communities and in terms of enhancing livelihoods. And in that sense, of course, she has quite a strong interest in innovation for inclusive development. She's also a leading research to develop new STI measures and indicators for the South African and African context specifically. She's also organized national, regional research and policy workshops on higher education, public research institutes, innovation and development. And another particular interest of hers, which that all relates to, is about bridging the research policy nexus. So over to you, Glenda.
Thanks, Jackie. Thanks, everyone, for the opportunity to open and introduce this webinar. I just want to start off by reminding you that this is a joint effort between the Center for Science, Technology and Innovation Indicators and the Development Capable and Ethical State Division of the HSRC. And it's an attempt to bring together different methodological and disciplinary expertises to look at some of our pressing societal and developmental challenges so that we bring multiple lenses to bear and can have more insightful and more opening up in the way we approach these issues. So today, thank you, Jackie, for reminding us that it's International Day of Climate Action and how fitting it is to be talking about how we harness digital technologies for climate change and mitigation and adaptation. And this is becoming one of our most significant sustainability issues and our issues in the climate change space to consider how digital technologies can drive and yield significant environmental benefits. And for us in South Africa, we have to acknowledge that we're a little bit behind perhaps a lot of it behind in this space. And we know how advanced the countries in the European Union, the high-income countries, are when it comes to adoption and adaptation of green technologies and digital technologies. And I wanted to share, I recently flew via Amsterdam during the day, and I was quite blown away, well, hopefully not blown away from the plane, but it was quite amazing as you flew over to see how virtually every single roof of every single large building had solar panels on the top, which I think that is something that we could be really picking up on far more in South Africa. It was very, very striking. So we know that the EU is very advanced, particularly in the fusion and the integration of digital technologies and green technologies. And that's a priority in the EU strategy. And you're going to hear more about this from Prof. Jindra. But what they have found is that despite this being in advance, there is only a smaller proportion and a very slow adoption of the integration of digital technologies. So there are twin technologies emerging, but the progress is very slow. So this raises questions for us as we grappling with our own technological challenges in South Africa and Africa. What can we learn from this experience? How do we avoid falling even further behind? How do we avoid the traps and the kinds of challenges that are experienced in high-income countries? And how can we kind of, to use one of the popular phrases, leapfrog, to be able to adopt technologies in a much more contextually appropriate way. So what we thought this webinar would really do is bring together this international set of expertises with our local expertises, because our colleagues in the HSRC have been working particularly on how technologies are used and enhanced for disaster mitigation due to climate change. And Jackie will introduce them shortly. So we've brought together Prof. Jindra, who we will be introducing now, to bring the current state of the art across the EU, and he will be talking about possible pathways for smart specialization. And then our HSRC colleagues will be sharing some of the contextual challenges and vulnerabilities in South Africa and identifying spaces for technological intervention. And then we will bring in some discussion on the implications and lessons for South Africa in conclusion. And we will use the opportunity to raise critical questions for our context and our capabilities. So I'm going to hand back to Jackie to introduce the speakers, and I'm going to invite all of us to use the webinar space, to use the discussion space, to use the chat to raise your questions, and to use this as an opportunity to start to network across institutions in South Africa and the EU. So with that, Jackie, over to you.
So good morning, everyone. I'm Darren Wisgary, the co-chair for today. I'll be introducing our keynote speaker, Prof. Bjorn Jindra. Bjorn is a professor in international business at the Department of International Economics, Government and Business at the Copenhagen Business School in Denmark. His main research interest is in the intersection of international business, innovation and technological change. His work investigates research and development and innovation in multinational enterprises. Currently, this includes investigating multinational enterprise strategies for technological diversification and research and development resource commitment. He also looks at the international diffusion of technologies. This includes work on technological upgrading of emerging economies, digital sustainability technologies, as well as hydrogen technology. So Prof. Bjorn will deliver his keynote address today on the topic of pathways for smart specialization in digital sustainability technologies. Welcome, Prof. Bjorn, and over to you.
Thank you. You're already at the center.
Be fine. Yes.
Yeah.
You can see the camera.
Good morning, everybody, here in the room, but also online. I would like to thank the HSRC for the invitation to join the HSRC as an international visiting fellow. It's a great honor to me to get the chance and opportunity to interact with the staff here at the HSRC and CESTI in particular. And this webinar is also a chance for me to interact with some of the other units within the HSRC that work on issues related to climate change mitigation and adaptation. The talk today will be basically looking at some of policy aspects and also empirical evidence that we have from two studies that looked at the intersection of digital and, you could say, green technologies. Now, this work is based on a larger project which I undertook jointly with Mateusz Lojzin. He works at the University of Bremen, and we were asked to engage in research by the European Commission, the Joint Research Institute in Severe, basically investigating the development of digital sustainable technologies by top R&D investors. The Joint Research Institute in Severe, one of their main outputs is that they gather data on sort of the top industrial private sector R&D investors globally. These are about 2,000 firms. And they were wondering to which extent do these firms contribute to the development of technologies that are at the intersection of digital and green technologies. There's another publication, this came just out this spring, where we basically take more the EU perspective, so from the regional perspective, not a corporate perspective on digital sustainable technologies. Both are freely available. You can simply download accessible open access for you. Now let's start. Can I change the clicker? It's somehow stuck. Let me try.
The arrow.
Okay, I can. Once we are trying to fix the technology here, I will continue. Let's first take a look basically at what the European Union has committed to in terms of climate change. They aim for a net zero greenhouse gas emissions, being carbon neutral by 2050. The previous European Commission engaged in a large package of policy measures, the so-called Green Deal, that related to climate, energy policy, transport, taxation, in order to reduce greenhouse gas emissions by at least 55% by 2030 compared to the 1990 levels. So where is the European Union actually standing with regard to this objective? They have been cutting across the board nearly a quarter in terms of greenhouse gas emissions so far. However, the progress varies across the different sectors. Greenhouse gas emissions were successfully reduced in power and industry, in building and construction, also in agriculture. However, in transport and mobility, emissions have been actually rising. So the record in terms of greenhouse gas emissions is mixed. Now let's turn to what the European Union policymakers think about the direct effect of using ICT and advanced digital technologies. If I say advanced digital technologies, that relates to AI, blockchain, technologies for example, the Internet of Things, of course. We need to remember that these technologies also use considerable energy resources. So there's a direct effect on greenhouse gas emissions through the energy consumption. So if the European Commission sort of thinks there is still room for efficiency improvements, so they're considering, as these technologies continue to develop, their efficiency in terms of energy use will increase. So that will allow us sort of to employ these ICT and digital technologies without having exploding large effects around this. So there will be efficiency gains that can reduce the carbon footprint of the industry. By the way, there are no regulations in place for the ICT sector with regard to their emissions, in contrast to the others we have just reviewed. And the European Union also assumed that the energy demand might be satisfied by renewable energies. Now, of course, we can question whether these assumptions still hold. If you consider recent reports coming out of the US, You might have noticed that some of the big tech companies, including Google and Microsoft, are concluding agreements with nuclear power stations for long-term energy supply at prices that are roughly double of what they are today. So what they assume is that with the rise of AI, blockchain, and a number of applications, the energy demand of the industry itself coming out of data centers will increase massively, and renewable energy will not be enough to fulfill these needs, and nuclear power is required. Nuclear power is, of course, relevant because it has no negative effect in terms of greenhouse gas emissions and delivers the energy. So it remains to be seen if these assumptions really sort of hold going forward. Maybe the previous European Commission has underestimated the effects of the energy use, the direct effect of energy use by ICT and advanced digital technologies. Now, there's another concept in European Union policymaking, which is very sort of frequently spoken about, which is the twin transition. So the twin transition is basically the integration of the digital transformation and the green transformation. And that also has a technological component. So we are talking about the potential benefits that derive from digital technologies for advancing the green transition, if you like. If you look, for example, at the work program for research and innovation at the European Union, the term twin transition probably popped up about 50 or 60 times. That might be true or not. So that is the notion of the twin transition is that related to digital sustainable technologies, which are basically technologies on inventions that have a green and a digital component, where both are used. Now, effectively, the notion of the twin transition emphasizes the enabling effects of ICT and advanced digital economies for greenhouse gas reduction in various sectors. So there could be positive enabling effect from ICT and advanced digital economies within the energy industry, for example. If you think about power transmission, if you think about the Internet of Things application and power grids, that could increase the efficiency and thereby reduce emissions. But there are also possible enabling effects in other sectors apart from energy, including sort of manufacturing, construction and buildings. If you think of Internet of Things applications in modern buildings such as these, they allow you through sensoring, data processing, and metering to sort of lower the use of energy and could contribute to positive effects. Smart cities, so using big data, Internet of Things in city utilities, but also in transport, are possible ways how ICT and advanced digital technologies can have enabling effects. And we have come across these examples. They are described. Singapore, for example, is a point in case for Internet of Things applications for a smart city. They have a whole digital twin of the city, which they can use to experiment, manipulate, simulate energy or parameters that influence the overall energy consumption. So what the European Union does is it emphasizes enabling effects and sort of downplays, you could say, a little bit the direct effects. Exaggerating here, but with a little bit of sort of distance, that's probably what the previous European Commissions thought about. Now, our research objectives in question was then, if enabling effects are supposed to materialize, we should be able to observe them also at the level of invention and technologies. So, and to which extent is that really the case, right? Do we see the combination of inventions that have a green and a digital component? And that required, of course, a suitable methodology to do this. We set out to basically look then at the evolution over time to understand a little bit the composition and the structure of these digital sustainable inventions, and to investigate where is the European Union well positioned to develop corresponding digital sustainable innovations. So about the type of data which we used, I'm talking here to some of the specialists from Science, Technology and Innovation Indicators. We decided to use patent data because we were looking at a longer period of time. It's standardized data, and we used information that comes out of the corporate patent classification, the so-called CPC, because here there is one advantage for us. It it covers climate change adaptation and mitigation technologies. This is the so-called YO2 category, and you see here the main parts of climate change and adaptation technologies, but they also cover digital technologies. It's not perfect because what they cover in terms of digital technologies is biased towards the energy sector. So we thought about ways how we could extend the identification strategy by using, for example, additional keyword-based approaches. So we developed an identification strategy starting out with the existing CPC YO2, YO4 classification. One should say that inventions that are in these two categories have been assessed by specialists, right? So they were not automatically, so people were assessing to which extent these inventions did fit these categories. This is an added value. We extended by keyword-based search. We particularly had to do so to extend the coverage of digital technologies, including also more recent development covering AI and blockchain, for example. What you see here is basically the result from our identification, 6 different search modules. And for a period of 2001 to 2018, globally, we were able to identify about 170,000 inventions or patent applications. We used priority filings. So priority filings are those patent applications that are initially done. So the first patent application of a patent family.
Colleagues, please mute.
And the advantage is that you reduce double counting, so the measure is more precise. Nelly Zikala.
Nelly Zikala, please mute. Moses, can you mute?
Okay. Thanks for allowing me back on the channel. Let's look again here at the evolution of these patents over time. We cover the period 2001 to 2018, and you see on the left-hand axis the total number of all priority inventions, which decreases, and in yellow you see the share of digital sustainable inventions in all priority inventions during the observation period.
And what we see on the right-hand side here is that by the end of the observation period, the share of these digital sustainable inventions in all inventions reaches only 1%. So it's still, although it has been growing, has been largely growing in line with overall patenting, maybe a little bit at higher rates, but we are talking still about a fraction of all patent inventions during the corresponding period globally that actually constitute what you could call digital sustainable inventions, so integrating digital and green components. Now, again, oops. Okay. Now, how does this sort of differ if we look at different countries globally? Well, you could say most of the countries are really between 0.25 and 1, a little bit above or close to 1%. So we see differences. Israel, India, and the USA seem to have higher rates of digital sustainable inventions in total inventions. The European Union, which is here in blue, is really just below 0.5%. So it's not, although Glenda sort of highlighted sort of the leading role of the European Union in international comparison, by this measure, we're probably more in the middle ground. And some of the emerging economies, including Israel and India, are actually doing also quite well in terms of developing these digital sustainable inventions. These are the country level trends over time. Basically, what you see here is that it has been increasing for most of the countries, which we were able to identify. Some peaks here for India and Canada, but more or less increasing trends across all countries. Now, on this, you see the distribution or the share of digital sustainable inventions by their basically climate change adaptation mitigation category. So on top, the top 3 areas in which digital sustainable inventions develop are related to climate change mitigation technologies in production and processing of goods. So this is, for example, all sort of manufacturing-oriented applications. So that category is fairly large with 28%, followed by climate change mitigation technologies in ICT, and that is to reduce their own consumption of energy. So that's about 20%. So this was also one of the assumptions of the European Union, so that there is still room for efficiency gains in terms of energy for the ICT sector. And indeed, from the type of digital inventions, sustainable invention we identify, there is a considerable share in the use of ICT itself. The third is related to energy generation, transmission, distribution. So everything from getting renewables on the net, smart grid efficiencies that result from the use of advanced digital technologies in the energy sector. These are the 3 most important. If we look at the end of the distribution, we were able to capture only very few patents in an area related to the capture, storage, and sequestration and disposal of greenhouse gases. So everything around CSSS technologies, very few, just 90 patents throughout the overall period, comparing to almost 50,000 for the area of production of processing and goods. Okay, now how we continued our analysis is by doing or creating a technology space that allows us to understand better major groups and clusters of related technologies. So from the overall group of 170,000 digital sustainable inventions, which clusters or related technologies can be identified that show sort of similarities, which frequently co-occur, right, and are very close to each other. So we did this based on the CPC, 4-digit CPC code, and we looked for revealed technological advantages in one of these codes. And we identified in total 62 CPC 4-digit codes that showed a specialization advantage for 3 sort of intervals in our observation period. Then we sort of identified visually on the technology space 4 clusters. And these 4 clusters of related technologies account for 53 out of the 62 specializations. So they cover quite a lot of those technologies that are relevant to digital sustainable inventions. So let's take a look. 4 clusters visually identified. If these the size of the nodes shows you to which extent, how frequently combination of codes or co-occurrence was. So if they are closer to each other, they are more related to each other. The most central and largest of the cluster is so-called cluster 1, which is about energy and data-related technologies. It also has specialization advantages covering 2 subclasses of climate change mitigation and adaptation technologies. The second cluster is very small. Also, we know already by the number of inventions related to CSS and greenhouse gas disposal. It's fairly isolated in our technology space down here. Cluster 3, where we have a large number of digital and sustainable invention, is around processing, technologies related to processing of goods, but also domestic applications. By domestic applications, we mean things like applications for the end consumer and applications in construction and building, like smart homes, etc. And finally, there is the cluster of transportation-related technologies. So that's everything around transportation mobility, including electric vehicles, for example. Okay, now in the subsequent analysis, we looked at how things change over these 3 intervals in time. We calculated specialization indices. So we counted basically the number of specialization advantages in each of these intervals for each cluster, and that gives you an idea whether a cluster sort of expanded or contracted over time in terms of the number of specializations it accounts for, and wireless networks. If you think about Nokia or Ericsson, for example, that would be companies engaging, large companies engaging wireless networks. You have also circuit producers, large circuit producers having subsidiaries in the European Union, in the Netherlands, Germany, for example. However, it's notable that the European Union lacks specialization in ICT for climate change mitigation and data processing methods that sort of dominate that particular cluster globally, right? So when we take a look at relevant specializations coming from the area of renewable energies, we indeed find specialization advantages around photovoltaics and wind technologies that are relevant for this cluster. However, on a global comparison, the European Union doesn't have a specialization advantage when it comes to nuclear power. We also looked at complementary technologies that are very close to those that are relevant for this cluster. And here, sort of further progress for the European Union could be possible by fostering technological advancement in technologies relevant for greenhouse gas emissions related to climate change mitigation technologies in the building sector, building and construction, and a key area here also energy generation, transmission and distribution. If we take a quick look at cluster 2, we already learned it's fairly marginal, it's isolated, it's very small, and the European Union as such, as a group, compared to all other global regions, doesn't have a technological advantage here. However, there's one in CCS technologies that mainly goes back to activities that come out of France in nuclear, in disposal. However, it's important to keep in mind from a policy perspective that the IPCC predictions assume that these technologies need to be used going forward if we want to meet the climate or global warming targets. So it's certainly an area that sort of in the mid and long term would need sort of more attention given the current size. Now, the most dynamic cluster, continuously growing over all 3 intervals during the observation period, is the one related to processing of goods in domestic applications. Here, the European Union shows specialization advantages when it comes to smaller areas such as additive manufacturing, working with metallic powder, solar heat collectors, domestic space heating systems. However, they lack specialization advantages that are relevant for this cluster when it comes to climate change mitigation technologies in production or processing of good wastewater buildings and technologies for the adaptation of climate change. So very central areas to this cluster, again, where the European Union so far has not developed specialization advantages, and one could perhaps conclude that given that the speed this cluster of digital sustainable inventions develops, that there is a risk that the European Union might fall behind. Finally, when it comes to transportation, interestingly, that cluster is contracting in terms of the number of specializations in each of the intervals. The European Union has actually most of its specializations in this particular cluster, which overall is contracting, right? So the European Union is able to engage in digital sustainable inventions in this area. However, overall, quite a lot of the specialization advantages are still associated with technology around combustion engines rather than electric vehicles, which is clearly sort of a key element going forward. Now, to come to sort of some of our implications from the evidence which we have seen, the extent of the integration of digital and green technologies is still very limited. Maximum 1% globally, European Union 0.5%. We can identify relevant clusters of related digital sustainable technologies that mainly evolve around energy, processing of goods, and transportation. The EU primarily lacks relevant specialization advantages around key ICT technologies, but also some climate change mitigation technologies itself. One way to address this problem is basically to look at smart specialization, which is a policy concept that has been very popular within the European Union over the last 2 decades, one could say, where you say if you are sort of lack specialization advantages, you try to advance related technologies that then allows you to enter and build bridges between these key technologies here in question. we need to keep in mind that for the overall assessment, to which extent ICTs and advanced digital technologies actually help us addressing greenhouse gas emissions, we cannot look only at the enabling effects. We need to consider the direct effects as well. So energy consumption that results from the use of digital and ICT technologies, and any changes at the system level, so-called rebound effects. So the verdict is still out whether, going forward, we really will see a positive balance resulting from the transition in terms of greenhouse gas emissions. That's important to keep that in mind. Just quickly, I know that Wilfried and Charles will talk more about this. From a technological point of view, quick sort of perhaps implications for South Africa with a question mark. In principle, yes, there can be enabling effects from ICT and advanced digital technologies. Perhaps a key area also in the South African context is related to the energy sector. So we are talking about efficiency increases, we're talking about transmission, smart grid technologies that allow us to efficiently manage the onboarding of increasingly available renewable energies. We are talking also about applications at the user end that allow to improve the efficiency and lower the energy consumption. That argument could perhaps be made. I know that our colleagues will also look at different applications of technology change for climate change in the South African setting, but this is an area that is promising. In general, probably important points from a policy perspective here are then, if you want to leverage the effects of digital technologies, one need to create better access to these digital technologies locally here. And that, of course, is related to our infrastructure and the connectivity in South Africa. Digital goods and services that can be imported are a relevant element here, machinery equipment and others, and services, consultancy services, for example. We have transfer and collaboration opportunities. So if we have subsidiaries of big tech companies present in South Africa, applications that result from interacting with these foreign players here in South Africa are an important avenue, and they have also building own domestic South African capabilities around around digital technologies, ideally. As with the sort of other countries, fostering sort of an ecosystem in which digital startup can drive, and there is an approach to open innovation, are certainly helpful in order to advance the diffusion of digital technologies in South Africa, but also its application in energy and other sectors. So overall, you could say policy focus on green technologies, which remain utterly important from a greenhouse gas perspective, but also trying to reap the benefits from digital transformation for the green transformation are key. And perhaps for CESTI, I understood from my visit so far that there are a number of efforts already making also indicators available that allow us to capture to which extent R&D innovation are actually targeting or are relevant for digital or green transformation. That is an important, I think, policy input in order to observe how this develops. So I think, I hope, despite the disruption, that time-wise we are still fine and could continue with our other speakers. Thank you.
Thanks, Bjorn. Thank you very much.
All right, thank you very much, Bjorn, for that. We'll go straight on to Dr. Wilfred Lunga's presentation. I'd like to give a brief introduction for Wilfred. He's a Chief Research Specialist here in the Human Sciences Research Council, but he's in the Developmental, Capable and Ethical State Division. He has a PhD in disaster risk management and extensive experience in education, environmental issues, climate change, disaster risk, and related fields. His research interests include prospective risk management, climate change, household and community resilience, and strengthening. He also has interest in using survey data to apply quantitative and qualitative methods in observational studies to evaluate interventions, programs, and policies. And he also, here at the HSRC, works on a large number of the multi-year projects that the HSRC runs. So, Wilfred, would you like to take it away? Wilfred, can you hear us?
Wilfred, can you unmute? Hi, Wilfred, can you unmute your microphone?
Can you hear me?
Yes.
Yes, now we can hear you.
All right, thank you.
Nice.
Thank you, colleagues. Actually, the scene has been set. Thank you so much for the presentation. There's quite a lot which has been shared and which is also mostly in line with what we are experiencing in Africa and also in South Africa. So my presentation mainly is going to be a reflection on the implications and lessons for South Africa from the presentation which has just been done. And we will be looking at contextual needs and capabilities which are in South Africa. And my first slide, actually, it has a question, which I think also the first presenter has answered. What are the key vocabulary features? What are the key vocabulary which features in a significant manner in developing countries? One of the vocabulary is already been mentioned. It's mostly climate change, but we also hear mostly in research circles, in the political circles, people talking about vulnerability, talking about artificial intelligence, digital technologies, a polycrisis. And among these, there is also a high cost of living, debt crisis, austerity, effects of biological hazards. We actually experienced one of the most devastating pandemics, the COVID-19. In Africa, we also talk about raising poverty, inequality, crisis, as well as climate change catastrophe, and the polycrisis, which has actually reached the critical levels. And when we look at all these concepts, you'll find that they can actually be demonstrated in the everyday life, and the issues of climate change can also be depicted in quite a number of ways, as shown in this slide here, which shows the regional climate change program for Southern Africa. When you look at it, you'll find that the countries represented here, especially in region 1, where we find South Africa, Botswana, Namibia, there's a lot in terms of significant warming and also reduction in rainfall patterns. Region 2, you find also climate change is increasing. Region 3, and if you look at all those countries which I'm just mentioning, there is there are letters which denote each of them. For example, letter A, it's looking at population pressure. Letter S, a stronger institutional base. W, weaker institution base. B, weak economies and poor infrastructure. So within the SADC region, 3A, for example, you'll find that there are quite a number of issues which are happening, especially experiencing high rainfall, but there is also a climate change which is reaching extremes, especially cyclones affecting those areas. In South Africa, there are parts where you see there is a stronger institutional base, which is doing quite well, but there are also other parts within Southern Africa where we have weak institutions. And all this compound actually the issues of climate change as well as inequalities and poverty. The next slide looks at human mortality impacts due to climate change. If you concentrate on Africa, you'll find that human mortality due to climate change impact is quite high in the Southern African region, where we have between 80 to 120 mortality rate, which is extremely high compared to other regions of the world. And all this is about climate change, which we have actually highlighted that is one of the key vocabularies which is featuring in almost every discussion in the research field. The next one looks at map of economic pressures areas in Southern Africa. Also here you find there are areas in South Africa which are experiencing high economic pressures. And when you look at these regions, you'll find that those are the areas which are impacted mostly by climate change induced hazards, especially the areas in Durban, I would say KwaZulu-Natal province, the Eastern Cape province, and also other isolated parts in Limpopo, the Northern Cape, etc. Then we also have problems of poor waste management, which exposes people to dangerous contaminants. This is mostly within the areas where we have got a lot of industrial activity, especially in South Africa. The Gauteng area, it's Gauteng area. We also have the areas in KwaZulu-Natal. They are also quite high. And then the areas which experience a lot of disasters, which are also due to climate change. You find South Africa also has got a lot of those areas which are being impacted, and the damage is quite high in those areas. So when all this, the question which arises is, what is it that can be done to actually deal with the issue of climate change, inequality? You'll find what has been presented actually resonates very well with what needs to be happening in the country and also in other African countries which are in Southern Africa. And this other map here shows the effects from 1959 to 2019 of floods which have been affecting South Africa over the years. You'll find also the areas in Eastern Cape, KwaZulu-Natal, they are actually affected by flooding almost every year. But not only flooding, but recently in the KZN area, we had a snowfall which had devastating effects. And when you look at some of the reasons why people were affected, it's because of inadequate public response, coordination difficulties, as well as challenges within the road safety, where you find people were caught unaware of that hazard when it happened. And despite some of the weather alerts which were issued in advance by the South African Weather Services, the scale and impact of the snowfall caught many off guard, and especially the disaster management authorities. And all this actually led to disruption, and that resulted in some fatalities. And also people not taking heed of the alerts which were shared. Now, what can we learn from this, and what is it that can actually be done? So we see the opportunity that digital technologies actually can be taken on board and be applied in a manner that will save lives. But however, there are certain challenges which we need to address first within the South African context. And what are these challenges? One of them is the digital divide, where you find that areas which are mostly rural or marginalized communities, they are currently experiencing limited connectivity. So this digital divide hinders efforts actually to make people aware of what is it that they need to do. These communities sometimes lack access to vital information and services, and this divide exacerbates also inequality, making it difficult to build resilience against some of the natural hazards and the climate change impacts. Besides the digital divide, there is also limited funding and capacity within the country. You'll find that the public and private sector funding for digital infrastructure is insufficient. Municipalities, as well as local governments, also often face budget constraints. And this actually limits the capacity to implement advanced digital tools, especially for early warning or even data collection, as well as post-disaster response. And this financial shortfall actually will affect the development of technology, including training of personnel needed actually to operate this. And this has been going on for some time. You find even research institutions currently, because of cost cutting measures, they are not even able to carry out some of the research functions which they're supposed to do. Then the other also issue which is hindering digital technology is data gaps. Currently we are really struggling, not only in South Africa, but in the region as a whole, including the whole continent of Africa, with inadequate data for effective decision-making. Data is often fragmented, outdated, or inaccessible. And this limits ability to forecast risks accurately. And the lack of reliable data on vulnerable areas and populations may hinder deployment of climate resilience strategies, as well as disaster preparedness. The speaker also spoke about policy. The first speaker also spoke about policy issues. So that's another gap within the South African context and the region, where in the policy and governance space, coordination among government agencies, local authorities, and the private sector is often weak. And this is due to clear policy frameworks, as well as governance structures. So at times you find conflicting mandates, and all this also result in some limited integration in broader development policies. And this slows down implementation of effective measures to deal with the climate change debacle. We also have problem of resilience of digital infrastructure. And I picked this, that also even in Europe, it's one of the issues. We have seen this, was it in Germany when there were floods? Actually, there were quite a number of issues, and recently in Poland. So South Africa's digital infrastructure, especially in the remote rural areas, is often vulnerable to natural hazards, which you'll find power outages, telecommunication failures, and physical damage to data centers during floods or storms can actually cripple response efforts. Then also the issue of disaster risk reduction coordination. You'll find that national, provincial, and local authorities do not always work in sync, and the involvement of civil society is actually limited, especially during disasters. If it's going to happen, you'll find usually it's when they are just giving relief materials. But for preparedness, there is quite a gap in that space. And then the other challenge within our context is data access and monitoring. You'll find that the government agencies, NGOs, private organizations often do not share data effectively. And this siloed approach usually hampers development of integrated or evidence-based strategies. However, there are some things which we can derive from these challenges. What is it that we need to do as a country or as a region? There are quite a number of things which can be done, which include strengthening digital infrastructure, which is there. This means that we can have broadband expansions so that we can actually reach those areas which are remote, as long as we make sure that we have reliable internet, and we also limit the use of tools. And this can actually help to reduce the use of tools on early warning and others. And we can also upgrade urban infrastructure. The other presenter was talking about smart specializations. So within South Africa, we can also develop our own smart systems in the cities, such as smart grids, which can require expanded fiber optics networks and upgraded energy grids. We can also promote digital inclusion and access. So this can be done through building digital literacy, especially the vulnerable communities, small-scale smallholder farmers, local authorities, who can then use climate platforms as decision-making tools. We can also, these are some of the needs: climate smart agriculture for food security. We know climate change hazards are actually affecting food production. And recently, the the Human Science Research Council actually carried out a study on food nutrition and security survey, which showed that climate change is having a lot of impact on the food production. So this is one of the needs which can actually be adopted, where we can use remote sensing, precision farming technologies, platforms that offer weather updates, market data, climate smart tips that should be accessible and affordable to our local farmers. We can also scale up renewable energy through smart technologies, as well as improve carbon markets and climate finance. Do we have any examples which we can cite and which also we can learn from? Indeed, yeah, there are quite a number of examples within the African continent, but I'll dwell more on examples which are closer to South Africa. We have early warning systems, and Mozambique is one of the countries which have improved their flood early warning systems where they use digital technologies, including satellite data, mobile alerts, and real-time river flow monitoring, especially on the Zambezi, which flows to the Indian Ocean. So they are quite doing very well. And this is one country where we can actually learn from. Malawi as well, through their Malawi Department of Disaster Management Affairs, they've been partnering with the World Bank to implement early warning systems that sends SMS alerts to communities about weather, about severe weather. And this program actually started in 2021. The only issue is that these are done on small scale. They are not yet shared to the wider communities. But these are some of the needs which, and also lessons which we can learn for South Africa. There are also climate data platforms. For example, the Climate Watch for World Resource Institute, tracks greenhouse gas emissions. And this has been highlighted in one of the global reports. And South Africa is actually doing this through the Council of Scientific and Industrial Research, CSIR. They launched what is known as the Climate Risk and Vulnerability Atlas in 2021. And this digital platform actually provides up-to-date climate data, which inform decision-making at local, regional, and national level. It also includes projections for temperature, precipitation, and sea level rise. And it's helping to plan for future climate risks. Actually, last week, I had a chance to attend one of their presentations where they were now even updating it so that it can provide future data or future data and information on what is it the weather will be like, showing quite various variables. In agriculture technology, Zimbabwe is using what is known as the Eco Farmer platform, which is backed by one of the companies that offer wireless services, Econet. So this digital technology is helping smallholder farmers to receive weather alerts, farming tips, as well as micro insurance. Then on renewable energy, Botswana and Tanzania are doing extremely well. The Botswana Power Corporation is partnered with international companies to develop smart grid powered solar energy. While in Tanzania, they've implemented an artificial intelligence powered solar energy solutions to increase energy access in rural areas. Then in climate financing is another need. Climate financing and carbon markets. South Africa also here, through the National Business Initiative, launched a blockchain-based carbon trading platform to track and trade the carbon credits. With regards to digital education and awareness, Zambia has started the Zambian Climate Smart Agriculture Program, which is a digital learning platform, and this also started in 2021. This includes e-modules on crop rotation, conservation agriculture, and the use of drought-resistant crops. And urban planning and smart cities, Durban is in the forefront on that in South Africa, but we also have Mauritius in that space. Then the digital water management, Lesotho is one of the countries which South Africa can learn from through the Highlands Water Project, integrated digital water management tools that use remote sensing and artificial intelligence to monitor water levels and forecast future water availability. So what are the implications for all this of harnessing digital technologies? The previous speaker actually spoke on this as well. So with regards to South Africa, adoption of digital technologies can actually result in energy efficiency and reliability. For example, if we have smart grid technologies that are integrated with digital tools like artificial intelligence and blockchain, this can improve energy distribution and reduce power outages. And this also can actually enhance energy security by incorporating solar, wind, and other forms of energy. In one of the slides, you'll find that South Africa, I didn't show it, but if we go back, you'll find that South Africa is endowed with a lot of solar radiation on this slide. So we can actually take advantage of this energy and improve energy security in the country. Some countries which are doing that, we have already highlighted. Botswana is already doing that, Tanzania. And another thing is addressing decentralized renewable energy access. Here, we can actually come up with digital technologies for payment systems that will be integrated with the grid of solar power solutions and expand access to clean energy. With regards to smart water management, this also is a good thing which can help us track water availability, monitor usage in agriculture as well as urban areas. Currently, Gauteng is experiencing serious water shortages, and we have been receiving a lot of messages of late on that we need to save water. So imagine if we have these technologies, actually, they can come in handy and deal with those challenges. Another thing which we can adopt is the flood prevention and water infrastructure resilience. South Africa actually can learn here from Botswana's digital flood mapping tool, which predicts flood risks and provides early warning to communities. So if we have digital flood mapping tools and real-time water monitoring systems, this could enhance ability to manage water-related risks. And these tools can help communities assess vulnerabilities and also prevent flooding. Then the digital carbon markets, we can also benefit on this, and we are already, because we are already implementing, as I've already indicated earlier, that through the national business initiatives, it can actually be much easier now to just replicate it in other provinces. Then with regards to climate finance transparency, so here digital technologies can improve transparent and efficiency of climate finance. So South Africa can actually better track and manage international funds for climate adaptation. We can also take a leaf from Zambia's successful deployment of digital carbon management tools, which are offering insights on how to increase engagement with international carbon markets and attract funding for mitigation projects. Then one very important thing which we also need to look at is youth engagement. You know, digital platforms can actually be used to engage the youth, especially in climate action through education and advocacy. Currently, there is what is known as the Africa Climate Action Initiative, which promotes climate awareness across the continent. So the current trends actually in the digital technology domain is that there's a lot of collaboration happening, especially on climate change adaptation programs. We have in Southern Africa what is known as the Southern Africa Development Community Climate Services Center. And this center utilizes digital tools for climate data sharing and early warning systems across the borders. So the digital technology is essential for improving transboundary resource management for water and energy. So we can say that's as a concluding remark that South Africa actually stands to gain significantly from adopting digital technologies for climate change mitigation and adaptation. You'll find that these technologies can actually enhance disaster preparedness. They can also enhance or improve agricultural resilience. They can also optimize renewable energy integration and support effective water resource management. However, for all this to be successful, those challenges which are cited earlier on, the digital divide, infrastructure limitations, need to be addressed. And also we need to have a robust policy support for where you find everyone is working together to address all these challenges. And there are quite a lot of success stories, lessons, which we can also learn from a number of countries which I have given as examples: Botswana, Lesotho, Zimbabwe, Tanzania, Mauritius, including the European Union. Already we have seen that even in Europe, they have areas where they have strengths, but they have also areas where they have some weaknesses. I was able to pick, for example, they were saying in the EU, there's lack of specialization in ICT for climate change mitigation. And for me, this is one of an area which requires quite a lot to be done. Thank you, colleagues. Over to you, Chair.
Thank you very much. Thank you very much, Wilfred. Okay, so we're just going to have a quick comfort break. On my clock, it's 11:28, so let's come back at 11:33. And we will continue then with Charles giving us a response to both presentations, and then we'll dive into our question and answer session, our discussion.
Right.
All right. Thanks very much, everyone.
Welcome back, everyone. I hope you had a good short break. For our response, we have Prof. Charles Ngoro from the Human Sciences Research Council. He is the strategic lead for the HSRC's Development, Capable and Ethical State Division. He holds a PhD in health economics and policy and has extensive experience in public health research. His research interests include the human dimensions of climate change, poverty and inequality, food systems, social protection, health systems financing, health systems and policy-oriented research in general, and evaluation of and impact studies. Prof. Charles Ngoro, I hand over to you.
Thank you very much, Chair. Maybe I can just show my face for a few seconds so that our visitors can relate the voice to the person. Thank you very much for the opportunity. My inputs are going to be limited because I think that the first and the second presenter have really touched on the many issues that I wanted to also relate to, particularly as it relates to what is the potential application for South Africa. But nonetheless, I see my role as one to provoke discussions and therefore to raise questions, which I may or may not answer myself, because part of our focus, as you know, Prof. Bjorn, is at HSRC is we always want to answer the question, so what? And we ask it in a way of, wanting to learn. What is it that we can draw from what, for example, you have presented? I think you gave us a very good analysis of pathways for smart specialization in digital sustainability technologies, including renewable energy, transportation, carbon capture, storage, and of course, even internationalization. So meaning that collaboration becomes quite an important part. I was amazed by the data that you were able to analyze and therefore be able to look at the trajectory of specialization in Europe and be able to therefore identify which clusters of digital technologies are being applied where and what new innovations were coming up. And in my mind, I started asking the question, but where are we in South Africa? Where are we as Africa? Because one of the questions that I'm hoping you will address when you answer the general questions is, when you did your comparison of some of the patterns of digital technology application, particularly in climate change, how did Africa compare, or was there no data or data sources that you could actually use? Because my suspicion, as Dr. Lunga just mentioned in his presentation, the issue of data is one of our biggest challenges. But I'm glad that our colleagues in CESTI are beginning to look at these indicators, R&D indicators. I don't know to what extent they are capturing comprehensively this digital sustainability interventions in climate change. So I found that quite fascinating that you were able to do this. But of course, the key issue that emerges from your presentation for me is not just about development of digital technology and its application, but it's about the methodology, the method that you applied to be able to come up with these results. And I would imagine, and because I'm trying to address the so what question, is I think it seems to me we need to possibly do similar stuff, work, even at a country level, but at continental level. So I hope Glenda and team are looking very keenly to see this, because one of the challenges that one sees when you started hearing the examples that Dr. Lunga was giving of applications of digital technologies in various sectors, that there is a lot that is going on, but we don't seem to have, if you like, a repository or a good understanding of what is being applied where. Maybe it is there, but maybe it needs to be enhanced because I haven't engaged with it. And I'm making a humble submission that maybe we need to start considering doing what I call a landscape analysis of digital technology applications in those various sectors. Because in a landscape analysis, you have a good sense of what is happening where in the context of South Africa, but I think more largely it would be nice to know it in the context of Africa as a continent, because we can then learn from each other and stop trying to reinvent the wheel in various aspects. So I really found that really your work fascinating, and I'm submitting that I think we need to do more work around what I'm calling a landscape analysis. But again, coming to the question of this, so what? I think Dr. Lunga, you've given quite a number of examples of how digital technologies are being used in the energy sector, in the disaster management, etc. But And you also raise questions around coordination, both at the country level, but also at the regional level. But the question that's coming to my mind is that even within SADC, which is the Southern African Development Cooperation, what then ought to be done more than what is there? We do have structures that have been set up, but you were calling them that we have some of them are weaker institutions. I guess you mean in terms of capacity and resourcing. But then what needs to be done to ensure that we have the capacity that over time, the European Union has, to the extent that they are able to identify, develop repositories for data on technologies across the European Union. I think there is a regional question of data and coordination. But then at the country level in South Africa, again, coming back to South Africa, it seems to me you raised the question that we need to have an appropriate policy support framework. You said policy and governance framework. That needs to be there. But the question is, what should that policy be? I can borrow from, in public health, when we look at issues of social determinants of health and the extent to which you need to address a multi-sectoral issue. Possibly we need to come up with policies that, if you like, you might call them climate change in all policies. Or should I say digital technologies in all policies? And what am I trying to say? I'm trying to say that maybe to enhance coordination at a policy level and hopefully to translate at a programmatic level is to make sure that climate change is a key component or is a key consideration of all the policies that we come up with. And so is digital technology as well. That could be an opportunity to provide for broader application of digital technology. But the other one is when we talk innovation now around this digital technologies and application, what kind of incentive regimes or disincentive regimes should we be creating in South Africa to allow for further development in digital technologies? Because I think Prof. Bowen was, one of their major findings was that there's less specialization in digital technology, particularly for climate change, even in Europe. And the question is, what about us? So if we want to enhance application and new developments in that area, what kind of incentive and disincentive regimes do we need to create so that we have sustainable digital and green technologies for climate change mitigation and adaptation? I know I'm asking questions because I think those are the questions that we need to address when we have a broader discussion. But it seems to me there is, in conclusion, that there is an opportunity for using digital technologies in the entire value chain when you look at climate change, from early warning, from preparedness to response, mitigation, and adaptation. But it seems to me we need to have a very good understanding of what exists and what is being applied where, and in what coordinated fashion should this be applied. So there are lessons to be learned from Europe. And my submission would be, as I said earlier, if we can have that landscape analysis, which includes all the indicators that track these digital technology inventions, then we'll be able to know what to use where and in what fashion. Chair, I would just stop there. I know I had a whole list of things to say, but they've already been said. I would rather leave the time for a more broader discussion with the audience. Back to you, Chair.
Thank you, Prof. Ngoro. You've raised some important points there about adding climate change and technologies in all policies. There's definitely some food for thought around that. Colleagues, I'd like to open the session for questions. So for those online, please raise your hand. And Moses, if you could please assist me with unmuting them. And Moses, if you can please give me access to the Q&A function, just make me co-host. For now, I'll start with questions in the room while people are raising their hands. Are there any questions?
Perhaps
Nazim?
I was saying perhaps we can start even answering what some of the questions which were raised by Prof, especially
Yes, I think.
yeah, on the issue of data. If I may come in quickly, just where he is saying what is it that we can do within the SADC, for example. The issue of data is a critical issue, not only for the SADC region, but the whole continent of Africa. There is serious issues there. So within the SADC, I'm of the view that we can actually enhance the SADC Secretariat's role in issues of coordinating. So they should play a more active role in coordinating, especially climate change adaptation activities, where they can, say, establish a regional task force dedicated specifically to disaster risk and climate change. That's one way. And Prof. Charles, I can also say the HSRC has already started working in that area. We are now having this biannual conference on climate change and futures in Africa. That's one way where we can actually share data, because if we have more of such function, workshops, conferences that solely focus on climate change, it can actually facilitate a stronger collaboration. So that's one way initiative which have already started. We can also even establish regional data hubs where we have a centralized, within the SADC, a centralized data repository where we can collect, analyze data on climate change impacts, socioeconomic vulnerabilities, and so forth. And we can also even have standardized data collection frameworks within the region, as well as promoting data sharing and transparency. So the issue of open data policies can also address that. Those are the few ideas which I think we can recommend. Thank you.
Thank you, Wilfred. Bjorn, I think you'd like to respond.
Yes, don't want to take too much time, but perhaps just on the question of the need for data from African and or South African perspective. More specifically, Charles asked, where was South Africa in our analysis at the global level? And as you could see, the extent of digital sustainable invention is still overall fairly limited. It is basically dominated globally by, for example, looking at companies by American and Chinese global players in principle. If you take the list of top 60 firms engaged in the production of digital sustainable inventions, only about 10 or 11 are actually coming out of the European Union. That leads me to assume that sort of the engagement of South Africa in the production of digital sustainable invention is still very limited. Now we need to keep in mind that we are looking at patent data, and that comes with severe limitations, and that also applies to digital technologies, many of those being in the realm of software, right? Not software is not patented to the same extent as other technologies. So we need to consider also other existing STI indicators coming from Innovation Survey, coming from our survey of our research and development activity here in South Africa, which we can use for a landscaping analysis. And I know that from the conversations I had with the colleagues here in the CESTI team, that they are working on this front, and perhaps sort of from a technological science and technology perspective, a landscaping analysis for South Africa in context, in global context, in context partially also to other African countries is feasible. And it's also feasible perhaps to establish an ongoing monitoring of how innovation and R&D efforts targeting digital and green technologies is actually evolving in South Africa over time. And I guess that would be something we could bring to the table. And I will continue this discussion with my colleagues here and how I could perhaps contribute making this work. When we actually planned, for example, a patent analysis for South Africa and African countries as part of this landscaping. So Charles, thanks for acknowledging that we are thinking in the right direction.
Thank you, Bjorn. Nazim.
Yeah, I think you've partially answered my questions. I've got something related to a diagram that you showed, which is the one with the different clusters and the comparative advantages of different groups of countries. And the one thing I noticed was that you had China there as well as the EU and others. And it's interesting to me that China was quite a bit lower than the EU in terms of the number of technologies or patents really that you've counted in the clusters, because recently we've read that China became the largest R&D performer in the world, and also it's the country with the most number of papers cited. Also, many of the high-tech multinationals have moved to China, so one would expect that its patenting behavior would be very high, or the highest. Does it mean that with respect to climate mitigation technologies that the Chinese are not really interested in those technologies, or is it perhaps a data effect? Because I mean, going back to your point also about using surveys instead of the patent data, patenting is dependent very much on your strategy as a firm, and it depends upon where you reside in terms of, well, geographically, vis-a-vis north-south dynamics. So which is it? Is it that they're not interested really in mitigation technologies, or is it because they is it a data effect? Because, well, just maybe to finish off the point, you also indicated that the EU strangely doesn't really have many patents in electric vehicles. And I know that China has got the best electric vehicles in the world. So there are lots of interesting, maybe not anomalies, but a lot of complexities, I think, in that data that you presented.
I think your gut feeling is right. Perhaps I did not properly introduce that slide because we were just coming out of that sort of interaction. The composition, the slide that showed sort of basically the number of specialization advantages for each of the regions for the relevant clusters. If we would look at so the overall output of digital sustainable inventions, then clearly the US and China are in the lead over Europe. So you are correct, right? The point there with the specialization was that the European Union actually has technological competences in many areas that are relevant for the production of digital sustainable technologies. In terms of output, if you look at absolute number and the share that goes to US companies and the Chinese companies, they are far in the lead. So absolutely, they are pressing for China in particular. They are also pressing and addressing technologies around various renewable energies, climate mitigation, adaptation technologies. They're very active in that part. Yeah, I think that was the point.
Thank you. And then we have a question online from Selelo Matimolane. What new digital technology solutions are emerging, and how can they be adapted to fit the needs of communities with low adaptive capacity, specifically looking at access and uptake? Wilfred, can I ask you to come in?
Okay, no, yes, you can hear me, I'm sure.
Yes.
Yes. Well, there are quite a number technologies which are emerging. And when we look at from what the question is talking about, especially here in Africa, we have mobile technologies. They are actually coming on board a lot, and for them to actually be accessed, we are looking at those which include basic features where you are just able to call and to send messages, and these can also even use can be used in low resource communities where you send SMS-based, they allow SMS-based systems to disseminate critical information, and they can also use simple SMS messages that work on the feature phones to ensure that the information gets where it is needed. We have also low power Internet of Things devices. These are emerging technologies which have got devices such as sensors, and they can also monitor weather patterns, water levels. If you go to some rural areas in Mozambique, such technologies are being used, especially along the Save Basin, which stretches from Zimbabwe, Mozambique. We can also use, these lower power Internet of Things, which can use solar powered devices. It's emerging technologies which can also be, adaptable to vulnerable communities. GIS mapping, currently, it's also incorporating indigenous knowledge. So it's some of the technology also which I think can be taken on board. Thank you.
Thank you. I don't see any other questions or comments online. Are there any others in the room?
Can I maybe just perhaps extend the I suppose the answer to Gora's original set of questions with regards to data? So I'm always thinking about how do we capture these technologies in our data, and maybe that last point made me also think that really we are looking at two divergent communities here as well, because I mean, on the one end you've got the really high tech climate mitigation multinationals and so on. On the other end, you've got climate mitigating technologies that are applicable to developmental contexts. And how you capture that data might be very different. For example, the whole thing about patents is there's not really much patent behavior generally in South African businesses because of the power relation disparities. So with regards to data, it just tells us maybe that we need more tools. We've got our R&D survey, innovation surveys, which are firm-based, but we also do need to really try and cover the other aspects a bit better. Just a comment, I think, really.
Thank you, Nazim. And then I also have a question, Bjorn. One of the graphs that you showed that India has quite a high contribution to digital sustainable technologies. And I'm just wondering, do you have any thoughts around why that is? Is it because of population size, perhaps, that they have more technologies, or is it because maybe they mobilize resources better because they have better STI policies or something? Do you have any thoughts around why they're such a big contributor?
I mean, by this indicator, what it showed is that they were sort of over proportionally dedicating sort of technological development measured by patents towards areas that are relevant for digital sustainable innovations. And that could be that they sort of are in a technological development trajectory that also takes off, addressing now these points. Right, similar the situation now in China. So you see emerging economies entering technological development on some of these technologies, and I think probably there's an understanding there that there's a good level of ICT competences in India, particularly when it comes to programming, consultancies, applications, and commercialization. And that, of course, helps in advancing these applications.
Thank you. Are there any other questions?
Can I add on that?
Please go ahead, Glenda.
So I think Nazim's raising a really interesting point that we need to think through and problematize, and that is bringing together these disparate fields of the high tech and the more frugal, grassroots, bottom up, inclusive types of innovation. And the Indian experience, quite some years ago, I worked with colleagues in Sri Lanka after the waves of tsunamis in the early 90s. There's a very strong expertise in what people call ICT4D, ICTs for development. And a lot of that work has been oriented by default to climate mitigation because of the risks of disasters from the weather patterns changing in these contexts. So what's interesting to me is how we speak back from these more global South experiences into the more high income countries, because often we're thinking how we learn from the high income countries back into South Africa and the global South. But we've been grappling often with these kinds of problems and might have good solutions that are not necessarily patented, but that are effective and efficient, and that, but might be, as Wilfred said, are too limited in scale. And the challenge is to be linking that to more commercial opportunities, wider scaling, wider growths. So I think there's something there for us to think about when we're talking about the landscape.
Thank you, Glenda. Wilfred, I see you have a comment in the chat. You maybe just want to speak to that.
Oh, okay, I was just adding as well to the technologies where we can have solar-powered Wi-Fi centers, especially in rural areas. It's quite a lot. And the issue which Glenda is raising, it's quite important as well. In that there is need really to upscale, because most of this technology, you find that they are just done like a pilot phase. And once the funding is not available, it stops there. So that's one area where we really need to see how best really we can scale up. And I totally agree with your point. So we need to find ways of how can we upscale these technologies so that they assist communities. Thank you. But I have also a question to my colleague. You know, I'm actually fascinated to learn that you indicated in the EU there's lack specialization in ICT for climate change mitigation, and yet climate change is a big issue. Why is it like that? I'm really intrigued. I just wanted to have an insight on that.
Yes. I mean, you could say historically, East Asia and the US have been dominating the technological development in ICT. That, you know, since its origin, in Japan, since the 1970s. So they're basically pushing the frontier, and with part of the global division of labor and globalization and trade, Europe sort of, you know, benefited from this, but had limited own capabilities. That is the policy perception of this has been changing in the past decade. Also due to the increasing role of China and the geopolitical tensions, quite a lot of the talk in Brussels is about also gaining technological sovereignty. So they were putting up big sort of schemes, also investment schemes, to attract, for example, investment that allows them to have chip manufacturing and development, or to extend their competences in this area. But exceptionally, in very large subsidies were paid to companies willing to expand, for example, in Germany, also other places, Netherlands. So the European Union tries to gain a little bit more sovereignty, technological sovereignty, so to say, in ICT-related fields, acknowledging the importance in general for economic development, but also the importance for climate change mitigation solutions. And yeah, that's probably also a point of importance for an African and South African perspective, because to a large extent, South Africa as Europe will depend on infrastructure that comes out of the US, or maybe also China, in terms of computational power, data centers, the most advanced AI models in machine learning, deep learning. This is happening in amongst a group of very few companies. None of those is European. None of those is South African. And we need to strike, I guess, a balance from using and commercializing these solutions, but also keeping an eye on building up our own capacity over time, long term. Because otherwise there's a great risk of dependency. So, for example, we will pay the energy price that Microsoft has been negotiating now with the nuclear power station. That will be sort of through our use of their sort of open AI models, for example, for predictions you or we would like to use for dealing with climate hazards, for example. These are models that use, these are developed by these companies that own basically the infrastructure. So that is something to also think about, what sort of dependency, what sort of own infrastructure is actually in place to gain also some sovereignty over being able to develop and advance these solutions going forward.
I see a hand from Charles. Please go ahead.
Oh, thanks, Chair. My question, I just wanted to maybe follow up. One of the when Probion was presenting the European Union position, and where he was able to clarify that at least they've been agreed an agenda to achieve zero emissions by, I think it was 2050 and so on. And in discussing digital technology sustainability, you also mentioned this idea that ICT, digital technology, there is an assumption that, of course, it will be energy, it will cause, what is it? It will improve energy efficiency. And of course, it is currently also helping in reducing GHG, green. So my question is, and you were saying we're not sure whether this assumption will be true all the time. Does he see any signs of this assumption holding for the next 10 to 5 years? And the reason why I'm asking is that here we are proposing that these technologies can help us in many sectors, but there seems to be a hidden risk that at some point, maybe the efficiencies gained from application might actually be attenuated at some point when the effect on greenhouse gas emissions is reversed. Will it continue to be a reduction? Will it increase? What does he think about this? Because it's a big assumption. So I'm saying, as we say, let's promote this, but we need to think about, I think you call them second order effects, but I'm not 100% sure. If you can comment on that.
Yes, I think future will tell. And as I try to illustrate with some of these recent cases of Microsoft, Google, Amazon, making big investments into sort of deals that will guarantee and provide them access to electricity. That tells me that they assume that the sort of direct effect from the use of ICT and digital technologies will massively increase going forward.